We started 7.5 yesterday, but all we got through was the basic idea of graphing parametric equations. Well, that's not all. We also got through partially the idea of eliminating the t, okay? I say partially because we're going to do a little more complicated eliminating of t today. I'm actually going to start on worksheet 14 and then we'll go back and do the examples on 13, okay? But 14 has a great warm-up. Again, our learning targets are to be able to eliminate t, to graph any kind of parametric, including using the calculator. Okay, let me see if I have a cursor. That would be those two, and then today we're finally going to get to talk about projectile motion. All right. This is the warm-up at the top of 14A. Probably the first thing I would suggest we look for is what are the where the endpoint's going to occur at, or what are the parameters for t. Yes, -3 to 1. So if I fill this little table in, I'd have -3, -2, -1, 0, and 1 as the integers. You could definitely put in decimals, but that sounds like a lot of work. All right, I'm going to do this one by hand real quick since there's so few points, and then we can do it on the calculator. So to find the x value that goes in here, it says take t, square it, and subtract 1. So be real careful you don't do silly things with negative numbers, but if you square this, it becomes +9 minus 1 would be 8. 4 minus 1 would be 3. 1 minus 1 would be 0. 0 minus 1 would be -1. And 1 minus 1 would be 0. Then the y definition is 2t plus 5. So we're not using the x to find the y. We're taking 2 times the t and add 5. So ignoring the red, we have 2 times -3, which would be -6, plus 5 is -1. -4 plus 5 is 1. -2 plus 5 is 3. 0 plus 5 is 5. 2 plus 5 is 7. So we had a definition of in terms of t that helped us find the x values, and a definition in terms of t that found the y. So when we go to graph it, we're only graphing the xy ordered pairs. We do have to indicate orientation. Does anybody remember what orientation is? Orientation is the direction that it graphed in as you went from -3 to 1. So you have to put arrows showing direction. All right, so if we start at 8, -1, and then we go to 3, 1, we're moving in this direction. Then it says 0, 3, -1, 5, and 0, 7. So we continued to go this direction. Any questions about the orientation? Everybody getting the same shape? So where were the endpoints at? Yes, they occur when t is -3 and when t is 1 because of this statement right here. And then they are actually the xy ordered pairs, so 8, -1, and 0, 7 in any order. It doesn't, you don't have to list them in a particular order, and you really don't have to write the t business underneath. The t window used, the only one that everybody has to have the same is this one. The window used for t needs to be the same. Everybody needs to say -3 to 1. And do you remember what we said we always are going to use for the t step? Yes, 0.1. We're just going to keep it at 0.1. All right, then for x and y, as long as it fits on the graph, I really don't care. I probably would have been lazy and just looked over here and said, well, the graph paper goes -10 to +10 and -10 to +10, so I'm going to go with that. But you really didn't need all that, right, for this particular shape. So let's go ahead and put it on the calculator quick. I am going to start from scratch here because Chadwick wasn't here yesterday. Chadwick, if you go to mode, go down, put it in degree because everybody check that you're in degrees because we're going to need that in a minute. But then put it in parametric mode. You good? Okay. Then when you go to y equals, now you have some crazy business there. Okay. We are going to put in the two equations we were given for x and y in terms of t. And to get the t, we have to use this button. Because it used to be in function mode, it was an x. Now that we're in parametric mode, it will give us a t. So the first equation was t squared minus 1. That goes in the x. T squared minus 1. You good? And then in the y goes 2t plus 5. But it will not graph correctly until you have in the window put in the right t values. We want it to have endpoints, and those occurred when t was between -3 and 1. So the min is -3 and our max is just 1. We leave the t-step at 0.1. If you watch the video from yesterday, you can see what happens if you change that. But and then I'm just going to be lazy and do -10 to 10 by 1s and -10 to 10 by 1s. You could definitely have a smaller window. It would be fine. Okay, if I graph, everybody good? Got the shape that we graphed on our graph paper? What did I do? Oh, this one is supposed to be +5. Thank you. Window, I have -3 to 1. Now, just one more time, if you want the little bouncy ball to trace it out so you can see the direction a little bit better, you arrow to the left over here and hit enter. And then down here, if you pick the choice, if you go down and then you arrow to the right or left, there's all different options. You can get a thick line, a thin line, a dotted line, all kinds of stuff. But if you pick the one that looks like a -0, it will trace out the line, but you'll see it as it goes. So that's the one I picked. Okay. Okay. Does it say go to as part of your error? There we go. I gotta go arrow down, hit OK. Okay, can you hit go to and see where it goes? It probably goes to something you need to delete or something. Nice. Okay. Yeah, I gotcha. People do crazy things, and then that's why I'm very thankful when it says go to. Okay. This is what our graph looked like. Now, this business about eliminating, by the way, just real quick, let's review. If you trace, it will tell you starting at -3. This is one of the endpoints. And remember, the only thing we can do is move forward. So you have to arrow right only. And then it will end at the other endpoint. When t is 1, we have 0, 7. Good, Chadwick? Is the trace working or not? No. Okay. Anybody else? Okay. Is it working now? Okay, great. ladies and gentlemen. Now we need to review what we did yesterday about eliminating t. Hey, man. How do we write this to eliminate t? Does anybody remember the idea? Perfect, thank you. So which one should we probably solve for t? The one that's not squared, you guys remembered. Okay, so it says y equals 2t plus 5. What should I do there? Keaton, you with us? Okay, and then what do I do to put it into the other equation? Nolan? So it would say? And that was x equals, right? So after we solved this one for t, we put it into this one. Now, I'm good with that form, okay? Anybody remember what we kind of talked about we could do, Kayvon? Perfect. You don't have to do that. I will accept it either way. But this is vertex form, but it's sideways vertex form, yes? Has the x and y switched. Questions? Yes. That either one is fine. Either one of the ones in red I'm good with, okay? On the quiz, I'm not going to be picky. All right. Now the weird stuff, okay? We are going to do some with trig functions in them. I want to graph this first because I think you'll like this. X equals 2 cosine theta and y equals 4 sine theta, okay? Now we are going to have to adjust the t window, but can you type those in? If you're going to use t instead of theta, but go to y equals, what was the first one? Maybe remind me. 2 cosine, and we're going to use t, and then y equals, thank you. And you can close the parenthesis at the end or not, it'll take it either way. If you go to your window now, we're talking about putting a value into a trig function. So what kinds of numbers have we put into trig functions in the past? We don't want -3 to 1, and it didn't tell us what to put in. It's a value of theta. Any ideas? 0 to 2 pi would work great. Okay, so let's put in a 0 and 2 pi, or you can put in 6.28, or you can put in 7, it doesn't matter, just so we make one revolution. Let's see what happens. Leave the t-step at 0.1. I'm going to leave my window -10 to 10 for now. Oh dear. Is yours going really slow? I wonder, it's just having trouble calculating. 0, what? Oh! It wasn't going slow, it's just tiny. Let's try to change our window to 0 to 7 sounds good, but I think we might need a little negative on the y. I'm going to do like -5 to 5. We'll have a better idea of what the window should look like. Why is this turning out a line? Hang on. I want to talk about what we're doing here, and then we'll talk about what it should look like. I think it's actually our t-step. Okay, where we're going with this, guys, is we have x equals 2 cosine of theta and y equals 4 sine of theta. The shape we're going to get, okay, if we do this right, is supposed to be an ellipse. Let me talk about y. How could I isolate cosine and sine? Is there something that, okay, if I make this a t and I make this a t, are we going to be able to solve for t? What would solving for t look like? Okay, how do we get t by itself? Is that what this means, guys? Does this mean cosine times t? It is a function. We can't. The only thing, anybody have an idea? Sometimes students come up with inverse cosine, okay? But that's really not what we're going to have to do here. It's not going to help us. All right. You ready for some magic? Square both sides of this. Square both sides of this. What would you have? X squared over equals cosine squared of t. Okay? Just a minute. Over here, we want to isolate the function. So we'd have what? Y over 4 equals sine, and then square both sides again. Y squared over 16 equals, okay. Anybody have any ideas where we're going with this? Kind of. What can we do if we add the left sides together, the right sides together? That's the right side. Yes. So if we added these, remember how you could do this? 2x plus y equals 7. 3x minus y equals 9. And you would add these together and get 5x equals 16 or something crazy because the y's drop out. It's okay to add equations together. So if we add these two equations together, x squared over 4 equals cosine squared, and y squared over 16 equals sine squared, what happens on the left when we add them together? Get x squared over 4 plus y squared over 16 equals 1. What should that be? Whose center is at 0, 0. And it's going in the x direction, how much? To either direction, yes. And in the y direction, 4. So it should look like, oh my goodness, that is the worst ellipse ever drawn. It's Mr. Potato Head right there on the screen. All right. So our calculator didn't even come close to that, right? I think we have to rotate a whole bunch or else do it in degrees. Okay, let's go back and set our window to, okay, wait. Tell me what we should set our window to, right here. That would work, right? -5 to 5 and -5 to 5. Good job. Okay, but then our t window is going to be the issue. But let's make x -5 to 5 and -5 to 5. Okay, go back up here. Oh, that's the problem? Wait a minute. What mode did I tell you to put your calculator in? Degrees. What does that not work with? 2 pi. Fix me, Tristan, fix me. All right, let's try 360 here. But you know what? If you're counting 0 to 360, do you think you should count by 0.1s? No. I think we should go by something a lot bigger. Let's try 10. Because otherwise I think the calculator's going to take all day, right? Now try it. Nice. Yeah, mine was so much nicer than that. Who's this? Who needs help? From 0 to 3, round and round and round. All right, guys. Well, we are very off task because Hofbauer messed that up, but we had fun. Okay. Maybe now you'll remember when you get to the quiz how to do these. Help me quick. Try these two on your own. Isolate the functions, add them together. Remember, you have to isolate the function first. Keaton, what's this one going to be? Okay. And this one? And then? So we will have? Which could be written. Good job. Okay. Yes? So when you get to the quiz, you're going to look at this and go, I kind of remember something about this. Okay. We just have to remember you're isolating, just like you did with t, you're isolating the function, but then we squared them and added them together to get 1. And if you had to, you could try to graph it. Yeah, we'll see how well that went, right? You got to remember we're in degrees. We definitely could have put the calculator in radians for that question, and 0 to 2 pi would have worked. But we need to be in degrees for the next kind. Did anybody need me to do 2, or you're good? Got it? Anybody want to read me their answer? Tara, did you try 2 yet? Marissa, do you have 2? Everybody good? Tara, we divided by 4 and then squared them, so that's where we got that one. You good? Any other questions? Okay. I need you to jump back to yesterday's worksheet because it has a better introduction to this idea of projectile motion. This is like, I love this section, but it's kind of a weird one because okay. From we have times 0 cosine of theta and sine. One is going to be the x vector, one is going to be the y vector. Negative 16 t squared, 1/2 squared. I put on 16. Find the box is really good circle. I just went ahead and put negative 16. This is the gravitational constant. Put in meters per second or feet per second, but the ones I put in is second. So rather than make you memorize all that, all right. All right. So the first example we have, and then it does say plus the initial height at the end. The first example we have on 15, I think, is this one about the soccer ball, or is this worksheet 13? 13B, yes? Yeah. Okay, thanks. Just want the video to make sure we know where we're at. Okay, Luigi's kicking a soccer ball. He kicks the ball with an initial velocity of 35 feet per second and an angle of 48 degrees with the horizontal. The ball is 2 feet above the ground when he kicks it. How far will the ball travel horizontally before it hits the ground? Okay, we're going to use those equations. Let's make a diagram. Okay, we did. Write the equations. Anybody looking at the reference sheets? What do you put in for x? Okay. T, we definitely need a t. V sub 0, but what does V sub 0 stand for? It's right on your sheets. Okay, initial velocity. What velocity did he kick the soccer ball at? Okay, That's a degrees. Yeah, that's not it. What's our velocity? I was believing you. 35 feet per second. That sounds a little bit better. Not that it couldn't be 48, but okay. And then what does it say to do after you do that? Times still? Cosine of the degrees. Yes, 48 degrees. And this is the one we had to be in degrees to do. We good? Okay, tell me what we're going to put for y. T. And you guys, that's the first thing people struggle with is they leave the t off and then it doesn't work. Okay, I don't know why, I do it too. V sub 0, 35 times sine of 48. Yes, as long as we're in feet, it just stays 16t squared. Plus 2. Where is Tristan getting plus 2? Initial height. Good job. All right, you ready to try this? Now we're going to need to do some thinking about our window before we try to graph it, so don't get ahead of us here, but type these in, and one of you lovely people are going to remind me what we just did. T cosine, oh, we put the 35, doesn't matter what order we do it in, then times cosine 48 degrees, okay? And then we had the same thing, T 35 sine of 48. There we do need to close the parenthesis because we're putting more stuff behind it. Negative 16t squared, or minus 16t squared. Don't do a negative or it'll multiply. Plus 2. All right, ready to try the window? Okay, what is t representing in this question? Anybody know? What is t commonly representing in the problems we've done? Time? Okay. So how long do you think the soccer ball is going to hit the ground? I don't think it's going to take 360 seconds. I don't think it'll take that long. You want to try 15? Okay. 0 to 15. Now, is it safe to go back to point 1? Yeah, because if you're counting from 0 to 15 and you did it every 10th, you'd have 150 calculations. I think the calculator can do that. Okay. What is x representing? I stood up here and told you x is the distance. So 0 to something. How far do you think the soccer ball is going to go? Yeah. What do you want to try? Let's just pick something. 100? Okay, let's put 100 in and see. It might not be enough. What's y going to represent? How high up it goes? Now, you might want to leave the negative 5 just because you remember how at the bottom of the screen, when we go to put trace, it's going to cover everything up if we don't have a little negative. How high do you think it goes? I don't think we need 100, but okay, let's try 60. Graph. See what happens. We could definitely make that a little bit smaller. Okay, I wouldn't care if you left it even, but you think 30 away is enough, or 50 away and up 30? 50 and 30 vertically? Okay. Beautiful. Good job, guys. All right. Question asked was, okay, actually, when you do this, I could ask you how long till it's ground, how high, how far does it land, what else? All the how high did which of those numbers? Y. And over up, and then it landed around. Now, this is really close to 0, right? That's how low the ground is. in a different. This question, how about we go with 39 away for next? Go on to another question. 39 or 40 feet away. Did we write all this down? 0 to, what did we put in? We probably could have done less. I just want to show you something real quick. If you pick a number like 0 to 2, if you get this picture, oh, 2 actually worked. Okay. If you get a picture like this, the ball did not disappear. You just didn't put in enough time for it to finish the path. Is that making sense? Okay. So 0 to 2 would have been enough, but, and then we did 0 to 60, 50, okay, that's fine, and 0 to 30, okay, good enough. And the answer to the question, do I have an answer to the question? What time the ball hits the ground was 1.7, did anybody catch that? That was our t value, and it will have traveled about 40 feet. More questions we could have asked, how high does the ball get? What did we say? Yeah, I don't know, might be 13. Will it, now I love this question. Will it clear a 6-foot defender standing 35 feet away? How would we figure that out? Perfect, go to x equals 35. As best we can, trace, if we get close to 35 feet away, right there, how high is it? 5 foot, not over 6 feet, okay? Now, if you wanted to try to get this closer to 1.5 or to 35, you could put in a little bit different t value, but we're going to move on. It looks like we'd have no, it's only 5 feet up. All right. You liking this? Kind of fun, huh? All right. Julie's throwing a ball at an initial velocity of 28 feet per second at an angle 56 from a height of 4 feet. How far away will the ball land? How much time until the ball lands? Tell me what I'm going to type in. X of t equals and y of t equals. Anybody? T, 28 is the initial velocity, times, then the same thing all over again, but sine. And then okay, let's try it with our current window and see how far we get. Not too bad? Okay, I totally forgot. Was this 40 something? 28 and the 56? Okay. All right, then I should be able to do the other one here. This should be 28. This should be 56. And the plus 2 at the end was supposed to be a plus 4, right? Okay. It worked. Did yours work? We didn't even have to adjust the window? All right, so trace along. How far away does the ball land? How close can you get? Ooh, this is pretty good. 0.18. It's almost 0, right? 25 feet away. These are only going to be an estimate. Let me show you what I mean. If I wanted to try to get that closer to 0, I could put in for trace 0.161, and it gets a little closer to 0. Whatever. It's basically 25 feet away that it's landing, yes? How long until it lands there? 1.6 seconds, yep. What was it? I forgot already. How many feet away? 25 feet away, 1.6 seconds after she throws it. Okay. This is another question like this. And then I want to go back to the other worksheet, just check if I need to do something different here. Oh, this is about inverses. This is kind of cool thing you can do with parametrics as well. Go to your calculator and type this question in from worksheet 14. Is this on A still? Okay. So I'm going to clear all this out, and I'm going to put in 3t minus 1 and t squared plus t. Now, they don't give us a value for t. So if I go to my window, I don't know, I'm going to do like -5 to 5 for t. And then I'm going to go down here and make this like -10 to 10 and -10 to 10. I don't know if this is going to work or not. Nice. Everybody get a piece of a parabola? Anybody know how we would graph the inverse? What is the definition of inverse? These are the easiest questions ever if you get the idea of inverse. Inverse is when you do what? No one remembers what an inverse is? Perfect, you flip the x and y. So when I flip the x and y, what is that going to look like? Was that supposed, this wasn't supposed to be a 2, that was supposed to be a t. All right, might change my graph a little bit, but guess what, guys? You just flip the rules. What is the x rule now? Yes, t squared plus t. And what is the y rule now? 3t minus 1. So there comes the first one. Whoa, did your second one go really fast? I don't know if this will work, so don't do it. I'm going to try zoom square just to square it up. They should look like inverses. Do you remember what inverses mean? They're a reflection across the line y equals x right there. Does that look like it reflected across that line? This vertex that's over here is now over here somewhere. Okay, so it just wants you to realize that inverses in parametrics are very easy. All you have to do is switch the x and y. I'm just not happy that they don't give us a window to use. Oh, here it said use -10 to 10. Well, -5 to 5 worked, so we'll go with it. All right, I have time to show you one more thing that's kind of cool. Let's try this question. It says on your calculator, I'm going to go to y equals and clear out all this stuff. I think so. This is 14b right at the top. This is a throw up problem, like you're going to throw the ball directly up. But what I want you to do is put in what for x, just put in an 8. And then it says for y to put in -16t squared plus 90t, thank you, plus 5. Okay, now I just want to do this all at once. So go to this second part in your second set of equations, go down one more, and instead of 8, put t. And then for the y, put exactly the same thing, -16 t squared plus 90t plus 5. Okay, now you're going to set your window. Your t, it says here, everybody looking? It says use 0 to 6 for t, 0 to 10 for x, and -10 to 200 for y. Okay, somebody tell me what I just said. 0 to Okay. I'm hoping mine is in simultaneous. Yeah, this is what, if you go to mode, the only thing that really makes this fun is if you go to mode, go down here and switch to simultaneous instead of sequential, and then hit graph. Oh, anyway, it's still not going to be. All right, let me show you. I'm going to go in and turn on the bouncy ball for both of these. And then I'm going to tell you what this is actually representing. All right, so here we go. When we did throw up problems at the beginning of the year, we talked about throwing the ball straight up and it coming straight down. But we drew it as a parabola because its height versus time was getting taller and then shorter. This is what's actually happening. We drew a parabola, but the ball is really just going straight up and down. So I don't know if it'll let me do it again. I think I have to change something. Maybe I'll just change this and then I'll do it. The ball goes up and it comes down. Do you see they're staying the same height? Okay. I want to show you one more thing though. I'm actually going to turn this one off for a minute. It doesn't matter. It's just what line it's drawing it on. I want you to watch the speed the ball moves. Anybody notice? It slows down and actually stops at the top and then it accelerates down. Is that what an actual ball does when you throw it up in the air? Right? It decelerates and then it starts back down. Okay? So I think this is a really cool picture of what's actually happening. Okay? If we made it go up higher, it would even accelerate more. All right, but we covered the basics today. We didn't get all the questions done on the notes, but that's okay. So the assignment, guys, is to finish these questions. These are projectile motion questions, okay? So in your packet, worksheet 15, all the circled problems. Worksheet 15, circled problems. That's where these came from. If you don't practice this, and we don't have a quiz this week or possibly even next week, are you going to remember this when it hits May and I ask you to do this? Okay, please practice this a couple times. Yes. The retake? Do you have a 4 or you did your homework or? Okay. So parabolas for Mackenzie. Everybody good? Kristen, you okay? You good? Yeah. Yes. Yes, next Friday. Hey guys, it's going. How about, am I still recording? Oh, that's not good.